which of the following represents the slope field for the differential equation dy dx is equal to 2 minus y. To solve this problem, I'm going to use reasoning skills to eliminate some of the choices. So I ask myself, when will dy dx equal 0? And this will occur when y is equal to 2. So when dy dx, which is equal to 2 minus y, is equal to 0, I get that by setting this equal to 0, and it's obvious that that will happen when y is equal to 2. Using this information, I'm going to find a graph which has horizontal line segments along the line y equals 2. This only occurs with answer choice A. When I look at answer choice A, right here along the line y equals 2, I see a series of horizontal line segments indicating that has a slope of 0. None of the other choices have that along the line y equals 2. So I know the answer is going to be A, and I could end here. However, I would like to demonstrate how the table of values can also help. Consider this table of values. When you are doing this, you can choose any point of your liking. I decided to use points along the along the line x equals 1. But again, you can choose any points of your liking. So I'm going to consider the line, let me get the highlighter here, x equals 1, which is right along here, and I'm going to look at all of these points, okay, and see if the slopes line up with what my table says. So when I have 1, 4, which is up here at the top, I have a slope of -2, since 2 minus 4 is equal to -2. And that is a negative slope. It's very steep. It looks like it lines up. If I use the point 1, 3, which is right there, plugging that into my differential equation, I see I have a slope of -1, and that lines up with what I have on point 1, 3. It's a negative slope. As we talked about earlier, at the point 1, 2, that has a slope of 0. And along the line y equals 2, I do have a slope of 0. Continuing on, at 1, 1, I have a slope of 1. And when I look at the point 1, 1, it's highlighted right there. I'm going to get a different pen. I'll highlight this out differently so you can see it better. But there's 1, 1 right there. And you can see it has a slope of +1. That agrees. When I consider the x-intercept, 1, 0, that has a slope of 2. And when I look at here at the x-intercept, that's pretty steep, and it does have a slope of 2. That works. Let me just erase this so it makes it a little more clear. The last one I'm going to look at is 1, -1. Plugging that into my differential equation, that gives me a slope of 3. And when I look at 1, -1, which is right here, I see it's pretty steep. It's positive, and that agrees with what I have right here. So this is sufficient evidence that the answer choice A is the correct answer.